All right, we're back here with the noisy string, and in the last little intro video we talked about the plan for what we're going to do, and now I'm going to jump into coding it. I've already done some work in this preliminary sketch. I've added a couple of sliders that I think might come in handy later on, so I've just declared those as global variables at the top and then created the slider objects with some little labels here as well in the setup function. You can look at tutorial 11 if you want to see how that's done. And there's nothing else going on here, it's just the default sketch. The only other thing that I've done is I've added a little bit of CSS here just to set the foreground color so you can see those labels and set the font to a sans serif font. But that's really not important for this example, which is why I haven't demonstrated it on screen. So let's go back to our sketch, and what we want to do is draw this line between these 2 points. So I'm actually just going to start by just drawing a regular old line, right? So I'm going to say let x1 equals, and let's make this somewhere on the left. So my canvas is 400 by 400, so let's just make x1 to be 100. And then let y1, and let's just make this halfway down the canvas. So I can just say height over 2. And then we can say let x2 equals, let's make that 300 on the other side. And let's say let y2 equals height over 2. And let's just draw a line. Line x1, y1, x2, y2. Okay? Very, very simple. The kind of thing that we did in the very first tutorial, just drawing a line. But now let's actually start breaking this line apart and add in these segments that I talked about. So what we want to do is not just draw one continuous line, but draw a series of little interconnected lines. Let's make 10 lines in between. So we can see here that we're only kind of going along the x, the y is not changing. So let's just loop over the x values. So let's say let I equals 0. I is less than, and I'm going to make a variable called length for the length of the line. I plus equals some amount, and we'll figure that out, okay? So let's figure out the length of this line. That's actually pretty easy to do. The length is just equal to x2 minus x1. Let length equals x2 minus x1. Oh, and I can see that I'm standing rudely in front of the code here. That's better. Yeah, so we've got these variables x1, y1, x2, y2. We just drew a line. Now we're going to comment that out and actually loop over that length of the line and draw a number of little line segments. So our length is just 300 minus 100, so it's 200. And then we said we wanted to make 10 segments, so let's make a variable called number of segments. Num segments, just num segs, equals 10. And that means that the length between each segment along that x direction is going to be the length divided by the number of segments. So let's say let seg len, segment length, equals length divided by number of segments. So that's what we add on each time. And what we want to do, let's just draw a point to begin with. So let's say point x1 plus I, and then y1. And I'll leave this old line here so we can kind of see the difference. And I'm going to change the stroke color. Stroke 25500. Oh, I'll make it blue. Set it back to black here. Okay. And let's make the stroke width a bit bigger too so we can see it more easily. Okay, I got an error. That's really good. I always like to see an error. Let's just check out what it says. Stroke width is not defined. I often make this mistake. For some reason I think of it as the width, but it's actually the weight. There we go. And you can see those little blue dots are over the top of the line. Now notice we didn't get that last blue dot drawn in. I'm just going to make that stroke weight a little bit larger so you can see it very clearly for the second part. So you can see here the blue dots, and there's not a blue dot at the end. And the reason for that is that we're going up to I is less than length here. So we need to say I is less than or equal to length. And there you can see we've got that final blue line. We've got all of our 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're actually drawing 11 dots here. There's 10 actual segments in between those dots. Now you might have been thinking at the start, why are we bothering to just do something as simple as just reproducing a line with a series of points? But you can see we've already run into one tricky little bug. So taking these very small steps, step by step, really helps us to stay on the right track. Also visually showing ourselves what's happening in the code at each step by changing the color, changing the stroke weight, so we can see the output of the code and verify for ourselves that it's working the way that we expect. That really helps. All right, let's now change this so that we draw not just a point, but a line. And what we're going to need to do for that is draw from the previous point to the next point. So I'm going to create two little temporary variables. So I'm going to say let px and let py. And they're going to start off as just px is going to be equal to x1. That's our starting point. And py is going to be equal to y1. So that's actually this first point right here on the left. That one's going to be x1, y1. So we can actually skip that in our loop, and our loop can start from the second point. So here I'm going to say let I equals seglen, and then that's going to draw from that second point. I can just verify that by running it again. You can see we're now drawing from the second point. But our px and py store the position of that first point. So we can use that to draw a line between the two. So let's actually say line from px, py to x1 plus I and y1 and y1. And now we should get a continuous blue line from the beginning to the end. And you can see we do. All right, now let's start bringing in some of this noise that we've talked about. So what I want to do is each time not just draw everything at the same y1 position. I want to calculate some up and down value so these points don't just stay on that middle line. They go up a bit, down a bit, down a bit, depending on how far we're along. If you remember from the sketch, that's exactly what we've got here. As we go along those different segments, each one's spaced out regularly in the x direction, but in the y direction, they're varying up and down a little bit each time. So for that, we can use the noise function. So I'm going to say let y offset equals some value from the noise function that depends on the I position. So I can just be our sample point. Now remember that the noise function gives a value back between 0 and 1. No matter what number you give as an argument, the return value will always be a number between 0 and 1. And the nice thing about the noise function is that it varies continuously. So if you give it the number 1032, you'll get a number between 0 and 1, so let's say 0.8. If you give it the number 1033, one very close to it, you'll get a number that's a little bit close to that 0.8. It might be 0.7, it might be 0.9, but it probably won't be 0. So as we go along in the x direction, our noise value is going to be varying continuously. So let's say y off equals noise I, and we want to multiply that by some number. So that's how much up and down movement we want to get. So let's say it equals that times 100. So here I'm going to say px, py. I've actually made a mistake in my code here. Just let me show you for a second. Let me just do this. I forgot to do something. You've probably already seen this and been shouting at your computer. Let's just comment out this line. The bug is that I'm never updating the value of px, py. So px, py is always that first one, and then I'm just drawing each one. I'll make this clear. I'll just make a random number, some random number between 0 and 100. You'll see that all of our lines are actually being drawn back to that first position. So what we want to do is not do that. We want to update the value of px, py each time. So I just need to say px equals x1 plus I, and py equals y1. And what would actually make more sense is to say let x equals x1 plus I, and let y equals y1, and then just use those two temporary variables just twice, because otherwise we're kind of repeating ourselves here. So if I run that code, you'll see we should get the sort of standard step along here. All right, that was a small distraction. Yes, I wanted to get my y offset. So we've got that here with this noise, and I can actually just add that onto my y each time. Now what we should see is the line goes up and down as it goes across because it's varying with the noise. You can see here the noise was probably some like 0, very close to 0, and as it went along it went down to 100, then back to about 0.5, and down again and up again. So that's how this noise function works. Now this sketch is actually running continuously. So I can make this noise move by adding on a little bit of the frame count value each time to my sample point. So let's say if I just put in frame count plus I, I'm going to get a little piece of string that moves continuously. So this is where we can start to play around with these amplitude and frequency sliders to change how much this is moving each time and how far up and down it's moving each time. I'll stop this video here and I'll come back in the next video and add in that element.